Hello and welcome back. Now we're ready to rotate the turret, and we'd like to do this using the mouse and that hit location from the trace hit we've done in the previous video. So as I'm moving my mouse cursor, the turret is rotating and facing the direction of the mouse cursor. And even when I click in the viewport and begin to play, I can still move the mouse cursor around to rotate the turret and set its direction. This will allow me to aim when I have the capability of firing projectiles. Okay, so to achieve this, we need to find the direction that we want our turret to point in. And once we've found that direction, then we can set the turret mesh rotation. Now, in order to get the direction that we'd like the turret to point in, we need to do a little bit of vector math. What we're looking for is a vector from the tank turret to our trace hit location. Now we can easily get the location of our tank or any of its components, such as the location of the tank's turret. We'll call this location turret location. And we also know how we can get the location of the trace hit. We'll call this trace hit location. What we're interested in is the vector from turret location to trace hit location. We'll call this vector toTarget. Now the vector math to get toTarget is actually quite simple. To get a vector from a start point to an endpoint is always the endpoint minus the start point. So if we take our trace hit location and subtract the vector turret location, then the vector that results from this is toTarget. Now once we have the toTarget direction vector, we want to convert that to a rotation so we can set the rotation of the tank's turret. And the F vector type has a built-in function called rotation. So if we took our toTarget vector and called rotation on it, this would return an F rotator corresponding to that direction. Now we do need to keep something in mind. The trace hit result is often going to be on the floor, and the vector from the tank turret to the trace hit result is not going to be parallel with the ground. This means that if we set the tank's turret rotation to the rotator we get from that direction vector, we might get something like this, where the turret is angled down towards the ground. But we don't want the tank's turret to rotate downward, we want it to still point forward. So this is the result that we want. In other words, we only want to change the yaw component of the tank's turret rotation. So that way it's pointing in the correct direction, but still remains parallel to the ground. We've only changed its yaw. So let's hop back into VS Code and create a function for rotating the tank turret. Now we're going to be rotating the turret on the tank, but we'd also like to rotate the turret on our tower enemy. And the tower is soon going to be created derived from base pawn, which means if we create a rotate turret function, we can place it here in the base pawn class, so that way both the tank and the tower will inherit this function. Since we plan on using it in both the tower and the tank, we can make this function protected. So I'm going to add a protected section, and any functions and variables we place in the protected section will be accessible in these child classes, but not in any other classes. So it's almost as restricted as private variables. Now this function can return void. I'm going to call this rotate turret. And in order to rotate the turret, I'm going to need a sort of destination to look at. This can be a F vector, and we can call this look at target. So the idea is if we have a function that we can pass in some sort of location in the world, then the function should result in rotating the turret towards that location. So let's go ahead and provide a function definition for rotate turret. So here in basepawn.cpp, just under the constructor, I'm going to implement rotate turret. And of course, I need the aBasePawn class name with the scope resolution operator here. So now that I have rotate turret, let's think about how we're going to implement this. The first thing we need is that toTarget vector, the vector from the turret component to the trace hit result under the mouse cursor. So this can be a local F vector called toTarget. And we're going to set it equal to the result of some vector math. Remember, it's going to be the destination minus the starting point, and the destination is look at target. And the starting point is going to be the location of the tank's turret. In other words, the location of turret mesh. So we can say turret mesh, and we can get the turret mesh location. Now, the way to get the world location of a component is with this function, getComponentLocation. It belongs to the useSceneComponent class, so all scene components have it. So from the turret mesh, we'll call getComponentLocation. So lookAtTarget minus the turret mesh location gives us the vector from the turret mesh to the lookAtTarget. Now, as I mentioned, we can get an f-rotator from toTarget using the f-vector's rotation function. So we're going to make an f-rotator, and we can call this lookAtRotation. And we'll set this equal to toTarget.rotation. That's a function call. So now we have the rotator corresponding to this toTarget direction vector. But the thing is, we only care about the yaw. We don't want to change the pitch or roll. We only want to rotate the turret around the z-axis and keep it parallel with the ground. Now we can do this any number of ways. For one, we can take lookAtRotation.pitch and zero that out. In other words, set it equal to 0. We can also take lookAtRotation.roll and zero that out as well. Now, after we've set pitch and roll to 0, we have the rotation we want, which is only the yaw component. This is one way to do it. Another would be to use one of the f-rotator constructor overloads. If we said f-rotator with parentheses and passed in some values, such as 0.f for the first, and the pop-up is telling me that that first input is the pitch, and then for the yaw, we can use toTarget.rotation.yaw, and then for the roll, we could use 0.f. Now what this does is creates a new f-rotator with 0 for the pitch, 0 for the roll, and the yaw component of the rotator returned by toTarget.rotation. So the value returned by this would give us the same result as what we did here with these 3 lines. So since this is a little bit more compact and elegant, I think I'd rather use this. So we can initialize the lookAtRotation vector with the f-rotator returned by calling the f-rotator constructor like this. So I'm going to remove this line down here, and now we have lookAtRotation. Now the last thing to do in this function is to set the rotation for the turret mesh. Now we can set the rotation for a given component using this function, setWorldRotation. Again, it belongs to useSceneComponent. And the reason we're using setWorldRotation rather than adding some sort of local rotation offset is because we have a rotation in world space. toTarget is a world space direction vector. We're taking the turret mesh location in world space and subtracting the lookAtTarget location in world space. So this is a world space direction. Therefore, the lookAtRotation is a world space rotation. So we're going to use setWorldRotation on the turret mesh. So we'll say turret mesh, setWorldRotation, and we're going to pass in lookAtRotation. So now we have a function that can take any target in the world and turn the turret mesh to look at it, but it won't rotate the mesh downwards. It's only going to change its yaw. So it'll rotate in a way that a tank turret should rotate. So we now have a function to rotate the turret. I'm going to challenge you to call this function to set that turret rotation. Call the rotateTurret function in the tank class. This is a protected function, so the tank class has access to it. Now, rotateTurret takes an f-vector, the lookAtTarget. You're going to use that impact point in the f-hit result from our line trace. So I'm going to leave it up to you to find the correct place in code to call this function. So pause the video and place the rotateTurret function call in the tank class. Okay, so we have our rotateTurret function and we're ready to call it. I'm going to go into tank.cpp and here's my tick function. Inside the if check for player controller ref, I have my hit result. And after get hit result under cursor has been called, the hit result will have valid data. In fact, we're using that hit result impact point in draw debug sphere. Now, since I don't need to draw the debug sphere anymore, I'm going to go ahead and delete that. And instead, I'm going to call our protected function rotateTurret. And for the lookAtTarget, I'm going to pass in hit result dot impact point. So now every frame, we're going to be rotating the turret towards that impact point from our hit result. Now, before I compile this, I'm no longer using draw debug helpers, so I'm going to go ahead and remove that header file. Okay, now I'm ready to compile. Okay, I'm back here in the editor. Let's go ahead and hit play and check it out. This is amazing. I can still roll around, I can move my mouse, and the turret is rotating wherever I move my mouse cursor. So this is awesome. Okay, so in summary, we've set the turret rotation, and we're passing in a look at target, which is an F vector corresponding to a point in the world. Right now, we're just using the trace hit result. Now, we put this function in the base pawn class and made it protected, which means that we were able to inherit the function in the tank class. And once we're ready to create a tower class based on base pawn, then that tower class is going to inherit this rotate turret function, and we can reuse it. All we need to do is pass in a new look at target. We'll work on creating a tower class derived from base pawn in the lectures to come. I'll see you soon.